stops the universe from collapsing into a single point? Wolfgang Pauli discovered a rule in 1924 that literally keeps you from existing as a puddle of collapsed matter. These are the 10 breakthroughs that led to quantum mechanics, and this is number 6, the exclusion principle. The problem here was, if electrons can occupy any energy level, why don't they all just fall down into the lowest one? Why do atoms have structure instead of every electron piling up in the ground state? Now, classical physics had no answer to this question, but the periodic table suggested that electrons definitely do arrange themselves in shells, filling up in a very specific order. Pauli proposed something new. No two identical fermions, which are particles like electrons, can occupy exactly the same quantum state. Now, this isn't a force that's pushing them apart. It's a fundamental rule of nature. If one electron is in a particular state, which is defined by its energy, its spin, its orbital characteristics, then no other electron can be in that exact same state. So electrons have to stack up in different energy levels, different orbitals, different spin orientations. They're forced to spread out. This is the Pauli exclusion principle, and it explains the entire structure of atoms. First electron goes in the lowest state. Second electron can join it if it has the opposite spin. And then the third electron has to go up to the next energy level, and so on. This creates the electron shells that give elements their chemical properties, and it's why hydrogen acts differently from helium, why carbon can form complex molecules, and essentially why chemistry exists at all. So without the exclusion principle, every electron in the universe would just collapse down into the same lowest energy state. So there'd be no atomic diversity and no life. Now, the exclusion principle isn't just about electrons. It applies to all fermions. It's what keeps neutron stars from collapsing into black holes, and it determines how matter behaves under extreme conditions. But by 1925, physics was still a mess of half classical and half quantum ideas. Someone needed to start from scratch. But that's for the next episode. Follow on for more and stay nerdy.